It is AMD. They got a new chip, and they're looking to take on NVIDIA.
This is about proving that AMD is a suitable competitor to NVIDIA's H100 chip.
The Magnificent Seven, quote unquote, I would add AMD to that list for sure.
47 analysts currently cover AMD. 37 have buys, there's 10 holds, there's no underperforms or sells.
Wall Street says that AMD stock is setting up for a massive year. And I agree, but not for the reasons that you might think. So in this episode, I'm going to answer one simple question. Is AMD stock finally worth buying over Nvidia, or has it already hit its peak? Your time is valuable, so let's get right into it. First things first, I'm not here to keep you hostage. Here's everything I'm going to talk about. AMD's data center GPUs and CPUs, their consumer CPUs for desktops and laptops, their gaming division, which includes GPUs for PCs and custom chips for game consoles, their embedded solutions for markets like robotics and self-driving cars, and of course, whether I think AMD is finally worth buying over Nvidia stock. Alright, let's jump in with data centers. The data center GPU market is expected to almost 7x in size over the next 9 years, which is a compound annual growth rate of 24%. So AMD is going to benefit big time from this AI boom, even if they just keep their current market share of 3% for data center GPUs. But that's not what's going to happen. AMD is in a great position to increase their market share over the next few quarters for a few key reasons. First, Nvidia can't meet all of this demand alone. As cloud service providers and supercomputing clusters keep placing massive orders for H100s, the wait times are growing to a year or longer. Guess who companies are going to buy from if they don't want to wait that long? Now let's talk about the GPUs themselves. About a month ago, AMD officially launched their MI300X, which is designed to compete directly with the H100s in both a single and 8 GPU configuration. This launch event actually kicked off a battle between AMD and Nvidia. See, according to their presentation, AMD's MI300X outperforms the H100 by about 60% when it comes to running large language models. Well, Nvidia published a blog post refuting AMD's results. It turns out that AMD didn't include something called TensorRT LLM in those tests, which is a piece of software that Nvidia released to optimize GPUs specifically for these kinds of workloads. I covered TensorRT LLM last fall right after Nvidia announced it, because it doubled the H100's performance for inference, giving Nvidia a massive lead over other chip makers at the time. That software package actually makes the H100s 25% faster than AMD's MI300X, not the other way around. But AMD followed up with a blog post of their own, where they redid the test using Nvidia's optimizations as well as adding in their own, and this time, their results showed that the MI300X was still around 30% faster than the H100s. Whether that ends up being true really depends on the specific workload and the rest of the system doing the processing. But AMD being able to compete with Nvidia at all this early into the AI boom is a pretty big deal. As a result, AMD is expecting to ramp up to $2 billion in data center revenue. But check out this quick clip from CNBC where Lisa Su talks about AMD's place in this market, and tell me she isn't lowballing that estimate.
Thank you, Lisa, for joining us today. When you went on stage, you reiterated a common theme that this market is growing much faster than you anticipated, and you more than doubled your total addressable market. What about your 2024 estimates? You said previously it was $2 billion in sales. Is that going to change anytime soon, given this demand?
To your question, yeah. I mean, look, the AI market over the last, year has just exploded, right? I mean, chatgpt, has, really kind of changed our perspective for what Gen AI can do. So we originally thought the total market for data center AI accelerators would be about 150 billion as we got into 2027, and now we think it's going to be over 400 billion. So yeah, much larger market. The reason for that is, frankly, everybody wants to use AI. We need more training. We need more inference. We did in our last conference call also talk about sort of the AMD opportunity for AI. We view next year will be about $2 billion in revenue. That's what we have, very, very clear line of sight to. But I have to say, customers want more. There's very high customer demand, and we have supply for a lot more than $2 billion as well. So we're excited to see how the next year will play out.
So just to reiterate for our audience too, because the issue with NVIDIA is that there's been so many comments with supply, especially when it comes to advanced packaging, TSMC. So you're not facing that.
Well, look, I think we all probably underestimated the demand for AI. If you just took a look at the market a year ago, I mean, there's been just a significant demand overall. So yes, it's tight in the semiconductor market, but this is what we do for a living. I mean, we spend a lot of time with our partners. We've been planning for this launch. We plan for success. So yeah, we have a significant supply for next year.
I'm not saying that AMD is going to magically beat Nvidia in 2024. And for the sake of full transparency, I have a lot more money in Nvidia stock than AMD, since their H200 GPUs are coming out in a few months, and their next generation Blackwell chips should be out soon after that. And while I'm excited to break them down for you, the truth is that both of those chips will probably be just as supply limited as the H100s, which makes this market big enough for more than one winner. But that's not the only market where AMD will gain ground in 2024. AMD's current 4th generation EPYC server processors were the first x86 data center CPUs built on TSMC's 5nm process. They run on AMD's Zen 4 architecture and can have up to a whopping 128 compute cores on a single chip. Another special thing about AMD's server chips is the size of their L3 cache, which is the shared pool of memory that all of these cores can access to transfer data between them. Increasing the number of cores and the amount of memory they can share are two tricks that AMD has been using to consistently take market share away from Intel since 2017. But these 4th generation chips took it to a whole nother level. AMD has more than doubled their server CPU market share since they released these latest EPYC processors back in 2022. And AMD's revenue from these chips grew by a whopping 50% quarter over quarter. Talk about fast growth. And photos of prototypes for their 5th generation processors, codenamed Turin, are starting to appear online, and they have some very noticeable upgrades. For example, these chips will be manufactured using TSMC's 4nm N4P process, and they'll have up to 192 cores on them. And each core will have access to roughly twice as much shared memory versus their current 4th generation chips. Now, Intel isn't exactly standing still here either. Their Sierra Forest chips are scheduled for release in the first half of 2024, and they could have up to a whopping 288 cores on them. That's 50% more than AMD's next generation chips, but these are all efficiency cores, and Intel's efficiency cores come with some big concessions, like not supporting hyperthreading. I'll break down the latest chips from both companies as they come out, so stay tuned for that. But for now, if AMD can keep taking big chunks of the data center market from Intel every year like they did in 2022 and 2023, their data center business will be booming. AMD is currently at an interesting crossroad as a company. They make roughly the same top-line revenues from all 4 of their major business units. However, it's their client revenues that grew by over 40% year over year and should keep growing for a few key reasons. First, the PC market has been shrinking for more than a decade now. Global PC shipments fell at a 4% compound annual rate of decline from 2011 to 2019, and they didn't pick back up until everyone upgraded their computers to work from home during the pandemic. And right after that, PC shipments fell again. But now, market analysts expect global PC shipments to actually grow by around 8 to 10% per year in 2024 and 2025 thanks to AI PCs. During their latest earnings call, Lisa Su said that AMD's client revenue grew by 42% year over year because the PC market conditions have already started to improve, and their current Ryzen 7000 series chips are seeing strong demand. And I expect that trend to continue with AMD's new Ryzen 8000 chips, as well as Intel's Core Ultra processors, both of which will have built-in NPUs. NPUs are neural processing units, which are optimized to run the neural networks behind many current AI workloads. Our computers already do a lot of AI processing today, from blurring out our backgrounds during video calls to video games supporting ray tracing and DLSS, which stands for Deep Learning Supersampling. If you add in AI-powered tools and apps like Microsoft's Copilots, OpenAI's GPTs, Adobe Firefly, or Wonder Studio, you can see the clear need for consumer-grade AI processors. And it's not just about creating content. I have no doubt that we'll be consuming the news, watching movies, listening to music, and playing games that might have been created by humans but are personalized by AI for each of us individually. To enable these kinds of use cases, AMD is working directly with Microsoft to make sure that the next generation of Windows will squeeze the most out of their on-chip AI engines. And that brings me right to AMD's gaming segment. A couple of weeks ago at CES, AMD showed off their new Radeon graphics cards, the RX 7600 XTs. These cards are priced at roughly $330, and they focus on powering processes like ray tracing for video games at 1080p resolutions, as well as generative AI and content creation workloads. That price point means they don't really compete with any of the graphics cards that Nvidia announced during CES, since they're anywhere from 2 to 4 times more expensive than AMD's. Instead, these Radeon cards will probably end up competing with Intel's entry-level Arc GPUs, the next generation of which should drop around summertime. So we'll have to wait and see the benchmarks and how well those cards end up selling. For now, I think AMD is in a great position to keep taking more of the desktop GPU market, just like they have been for over a year now. Recent estimates show that AMD owns around 17% of the market, up from 10% 4 quarters earlier. Even though AMD's consumer GPU sales are up year over year, their overall gaming revenue is down by 8%. How come? Well, because AMD also makes the semi-custom chips for both Xbox and PlayStation, and the time between new console releases is getting longer and longer. Lisa Su pointed out that even though console chip sales have declined in line with AMD's projections for this point in the console cycle, overall revenues from this generation of consoles is significantly higher than previous generations thanks to strong demand for both the latest Xbox and PlayStation. But I should point out that the Xbox Series X and the PlayStation 5 both came out in November of 2020, which was also the middle of the pandemic. Those consoles are now 3 years old, and the world has long since opened back up from the lockdowns. So whenever the next generation of game consoles do come out, they might not see as much pent-up demand as they would have during the pandemic. Also, thanks to the rise of mobile gaming, the global game console market is expected to grow by a compound annual growth rate of just 5% for the next decade. So this probably isn't the market that will move the needle for AMD over the long term. And that brings us to AMD's embedded segment. A few years ago, I made a video about Tesla switching from Intel's Atom CPUs over to AMD's Ryzen APUs in the Model 3 and the Model Y. AMD's chips are also in the Tesla Model X and Model S. Well, AMD announced 2 new automotive chips at CES. The first chip is AMD's Ryzen embedded V2000A, which is designed to power driver dashboards, passenger displays, and infotainment systems like Tesla's. This chip has 6 second-generation Zen compute cores and can come with either an integrated GPU or a more modern discrete graphics chip depending on the number of displays that it needs to power. The second chip is called Versal, which focuses on advanced driver assistance systems. This chip comes with 4 ARM compute cores that act as AI engines and 1 FPGA, or Field Programmable Gate Array. The combination of programmable logic and AI acceleration makes these chips great for applications like object detection in forward-looking cameras, in-cabin monitoring, parking aids, using LiDAR or radar for object detection and tracking, and of course, autonomous driving. Honestly though, I really wasn't impressed with these chips. Ryzen 2 is 5 years old now, and even the FPGA they chose is turning 3. I know that automotive chips need to pass a ton of regulatory, reliability, and safety tests, but AMD competes with every other major chip maker in this market, and for good reasons. The global smart car market, no, not that one. The market for connected vehicles equipped with some level of autonomy and other advanced technologies is expected to 4x over the next 9 years, which is a 17% compound annual growth rate. That's why Nvidia has their Hyperion hardware platform for autonomous navigation, Intel has their very successful Mobileye program that got spun out into its own company and even went public back in 2022, and Qualcomm's latest Snapdragon chips for the auto market can power advanced driver assistance and infotainment systems with a single chip. And Qualcomm's chips are built on a 4nm process, while AMD's Versal chip is an older 7nm one. But to AMD's credit, Tesla keeps picking their chips, so I'm probably missing something important here. Alright, I know this video is a little long, but I want it to be thorough since AMD competes with Nvidia in just about every market I covered. Data center GPUs and soon CPUs when Nvidia's Grace chip comes out, consumer GPUs, and in a few quarters, consumer CPUs when Nvidia starts building ARM chips for Windows PCs in 2025, and at least a few different markets for embedded chips, like robotics and smart cars. Nope, still not you. So if you feel I've earned it, consider hitting the like button and subscribing to the channel. That really helps me out, and it lets me know to put out more deep dives like this. Thanks, and with that out of the way, there's really only one question left to answer. Would I buy AMD over Nvidia stock right now? Well, the answer is actually yes, but not for the reasons you might have thought if you didn't just watch this entire video. AMD's MI300X is a legit competitor to Nvidia's H100s, even if it doesn't beat it. And AMD's 4th generation EPYC CPUs are strong competitors to Intel's Xeon chips. Their Radeon GPUs are slowly taking market share away from Nvidia's GeForce cards, and they dominate the chip market for video game consoles. On top of that, we know that Nvidia has way more demand for their chips than they have supply, at least for right now. And that means that AMD will keep gaining market share in these markets, which happen to be some of the fastest growing markets on the planet. This is exactly why it's so important to understand the science behind the stocks. Thanks for watching, and until next time, this is ticker symbol U. My name is Alex, reminding you that the best investment you can make is in you.